and we run it. Oh, there we go. There's our answer, and what comes out of this is what we've wanted all along, a model. Now, a model is just a fancy word for recipe here. Just a set of instructions to take inputs, turn them into outputs. And our model reads, if we're in the red region, call it red. If we're in the blue region, call it blue. Job done. And so in comes a new bottle of wine. Red or blue? Red. But we could have chosen a different algorithm. There we go. Let's pick the tree and run that thing. Here is our recipe. And that's a different recipe from the previous one, right? And in comes a new bottle of wine. Blue. Troubling. Most troubling. If you look in any textbook and ask what is a reasonable, classic, respectable algorithm to use for this situation, some textbooks will tell you this one, some textbooks will tell you that one, some textbooks will tell you both with a completely straight face. These are the things you need for this situation. Okay, so then you follow the textbook's advice and you end up in this situation where one of them says we'll like the bottle, one of them says we'll hate the bottle. They can't both be right. So which one of them is lying to us? Who is the imposter? How do we tell? Well, we remember that the whole point is, does it work on new stuff? And so we simply see which one actually does work on the new stuff. The point is to generalize beyond our data. So that is how we evaluate. Let's find out who wins on new data. So in comes some new data, and we apply both of our recipes to it. And of course, we get different answers. And I'd like to remind you, when we ran these two algorithms on our initial dataset, the training dataset, they both gave perfect performance. They managed to split the space so all the red went to red and all the blue went to blue. No mistakes. So both of them had 100% performance scores. But now, look at these results. Because they're different, one of them will probably be worse than the other. So let's find out who. How? Well, let's drink some wine for science. Here are the correct answers for that dataset. And all we need to do for our fancy statistical testing, never mind what models it all came from, you can forget all that at this point. Compare the desired answers with the answers given, and I feel like I have a preference here. I don't know if anyone else does, but I sort of strongly prefer the one on the left. And then I would iterate towards my solution with that one. And I would do a careful launch test before launching it, which we'll talk about later. So what is machine learning? It's an approach to making repeated decisions that involves algorithmically finding patterns in data and using these to make recipes that deal correctly with brand new data.